This here is sodium permanganate added onto water. And this actually has a chemical change associated with it. All of a sudden you get something that was initially clear. When you put it in water, it becomes purple. Color change, chemical reaction. Yeah, right? Pardon me? It can be a mixture, but usually if it was a purple thing and another purple thing, that would be the case of, a purple and then we put it back in, it was purple. That would be an example of a mixture, right? But the fact that you had something that was initially clear and you poured it into another solution. So we said a color change, right? The formation of a solid, the formation of a gas, the absorption of heat. So those are ways that we win whether or not a reaction has occurred. We also said odor, right? We can smell it, right? Whoever smelt it dealt it, right? Okay. So I said when we add sodium permanganate to water, sodium permanganate is clear initially. But when we add it to water, it has a reaction that occurs. And as a result of that, it changes color. We get a purple color. Chemical change or physical change?
Chemical.
Chemical. So if I have sodium phosphate and iron nitrate, and I add those two together, I get precipitation. Precipitation is the formation of a solid. It starts to get cloudy, and then after a while, that cloudiness will drop to the very bottom, and you'll have a solid at the bottom, right? Chemical reaction? Chemical, right? Alka-Seltzer. Any of you guys plop, plop, fizz, fizz? Oh, what a relief it is. So if we add Alka-Seltzer to water, what happens? And it forms gas, right? Chemical reaction. Fireworks. Okay, chemical reaction. Rave, glow sticks. Chemical. How many of you guys run into walls? Never? Every once in a while? Do you ever have to use those ice packs where you have to crack it open and put it on your head because you just ran into a wall? Right? Okay, that ice pack, is that a chemical reaction? Chemical, right? It's a chemical reaction. I know it says evidence of a physical change. Oh, no, it's actually a chemical reaction because you have water, the transfer of heat itself from one thing to the other, right? So you're transferring to the environment. That part is the physical part of it, but the chemical part of it is the actual reaction that occurs. So in the context, you got to talk about the book, right? You're putting a certain chemical, ammonium nitrate, into solution, and you're dissociating those two ions. And as a result of that, you're losing energy. So it actually is a chemical change. But I'll write them and tell them we need to fix that, right? Good. Okay. So here we're going to be talking about chemical reactions, right? We're going to be balancing chemical equations. So I have sodium is going to be reacting with water. What is the chemical formula for sodium? How many of you guys have your periodic table? Got it? Everybody got theirs out? Never leave home without it, right? Okay, sodium. What is the chemical formula for sodium? Are you sure? You want to put money on that? Somebody say NO? Na. Okay, sodium is Na. Water. Now this is going to make what we call sodium hydroxide. That's going to be NaOH. And it's going to make hydrogen gas. And we know that hydrogen gas, chemical formula for hydrogen gas is hydrogen. Are you sure? Hydrogen gas. Have no fear of ice cold beer. Have no fear of, are you sure it's just H? It's H2. Okay, because we know that hydrogen is one of our diatomic elements. When hydrogen is all by itself, it's always going to be H2, right? What other elements are diatomic? Diatomic. Oxygen, nitrogen, chlorine, iodine, bromine, fluorine. That's right. So there's 7, right? Okay, so we have this chemical equation. You guys see the chemical equation on the board? Okay, is it balanced? No. Okay, how do I balance it? I put it in Google and I get the answer? No. Okay, so help me out here. So what do I need to do? Tell me how I go through this process. Don't just give me the answer, give me the process. Okay, wait. Not again, let me see. We want to walk me through it. You're teaching me how to do this. You don't just tell me the answer. That isn't going to help me, is it? Okay, so I break them up. I have Na, H, and O. Okay. Okay, so the reactant side is on the left. All right. Okay. I have 1. Okay. 2 hydrogens and 1. Okay, what about on the product side? Okay, so I have N is 1 and 1, right? Is that balanced? H is 2 and 3. Is that balanced? Okay, what do I need to do to make it balanced? So you're telling me I could just magically put another H on there? Ah, okay, so that brings us to that first thing. One of the rules, always. What was that? It's H2. Are you making fun of my writing? It's okay. Okay, so the rule is, right? Once you have all of the chemicals and they're written correctly, you can't just start adding stuff to make it work, right? Because remember the law of conservation says that you can't just magically create stuff. Okay, so we can't just magically throw something in there because it's not working out for us, right? So we can't just magically add an H there, okay? So we need to use those coefficients at this point. So how can we use those coefficients? Somebody said you guys are all talking pretty fast and I'm a little slow. So what do I need to do? I have a 2 and a 3. Is that balanced? Okay, so what do I need to do to balance it? So are you saying that I need more H's? Okay, so you're saying I need to put a coefficient. Where do I need to put a coefficient? So I just put it right in front of the hydrogen? So you said I need to put a 2 here. Is that what you're saying? So I put a 2 in front of sodium hydroxide. So I need to put a 2 here, and I need to put a 2 here. Okay. Well, let's do the count first. Let's do the count. Okay, so now we have, I'm going to cross that out. So then that's 2 sodiums. How many hydrogens are on the reactant side? How many oxygens? Okay, on the product side, we have 2 sodiums. We have 4 hydrogens and 2 oxygens. Is that balanced? Man, you guys, it's like you guys are learning something, right? And you guys already took chemistry before, right? It's because of her. So she's earning her money, huh? That's good. We'll see about that. If you guys all get A's in the class, I'll push for that. So if you guys get A's, then I'll push for it. Okay, so you guys see how that works? Not too hard. Piece of cake, strawberry with chocolate frosting. Okay. Okay, so you guys on the other sides, how are you guys doing? I got some text messages. Julia, you got it?
Yeah.
Ara, you got it? The chemical equation?
Yes, I got it. I understand.
Yeah, you should have this already written down. You don't need to write this all down. Yeah, if you guys have this already, you're good. You're good to go, right? You guys should have this on your handouts, right? Okay. Okay, so let's move on. Let's sit there and talk about it. So we know that we have coefficients. Once we have those chemicals thoroughly in place, we know that they're right. Then all we need to do is adjust the coefficient, right? We're not going to mess around with the subscript. We're only going to adjust the coefficient. That's where you put your notes. That's the lines. That's for your notes. Yeah, they're yours. Yep. They're yours for the rest of your life. Yeah. Okay, so now at this point, we've only been talking about those chemicals. We need to talk about the states because we need to know if it's going to be a gas, if it's going to be a liquid, or if it's going to be a solid, because that is going to play a part in how things react as well too. Are you guys with me? Good. Okay, the way that we tell in a chemical formula if something is a gas, we put a G next to it. So we put parentheses, G, parentheses, right? The way that we tell that something is a solid, we put an S next to it. The way that we tell that something is a gas, we put an L next to it. The way that we tell that something is aqueous. What is aqueous? Aqueous means that it's been dissolved in water, right? Remember we talked about those solutions, right? An aqueous solution means it's dissolved in water. If you hear the term solution, you always assume that it's water unless they tell us it's something else. Okay, so you would assume that it's aqueous. Okay, so I'm going to ask you a question here, right? So earlier, we wrote the chemical formula. We had Na plus H2O yields sodium hydroxide that's a no. You guys are making fun of all my handwriting. And hydrogen gas. Okay, so we know that sodium was a what? Was it a solid, liquid, or gas when we put it into that solution? You guys remember what it looked like? Sodium. Let me give you a hint. At room temperatures, all the metals are solid except for one, and that's mercury. Mercury is the only one that is a liquid at a room temperature. Okay, so is sodium a metal? How many people say sodium's a metal? Raise your hand. Sodium, it's a solid, that's right. So metals are gonna be solid, right? Except for, which metal did I say is a liquid at room temperature? Mercury. Okay, so we're gonna put an S here. Okay, yes, that's an S. Okay, for solid, that's right. Water. Is that a solid, liquid, or gas? Okay, so we're gonna put what next to it? So we know that sodium hydroxide, since it was in that all that water, it's gonna be a solution. So that guy is gonna be aqueous, AQ. And hydrogen is gas, so we're gonna put a G. A G like me. Okay. Okay, you guys got that? Simple, not too hard. So every chemical equation, you should be aware of the state of what you're working with. Okay, what did I say about that? I just said it. We assume that it's aqueous unless they tell us otherwise. Okay? So, not too hard. Okay, other side. How you guys doing over there? Are you guys good? Thumbs up? Good, good. I like to see thumbs up. Okay, I'm gonna clear my screen. Okay, so rules, do's and don'ts, right? Okay, so we'll start with the do's. First do that you always want to do, you want to make sure you have the chemical formula of the compounds or the molecules correct. If your chemical formula is wrong, everything else is going to be wrong. Okay? So chemical formulas of each of the compounds have to be correct. Okay? So that is the very first do. Okay, now before you start doing anything with the coefficient, you've got to be sure that those formulas are correct. Yes, ma'am. You do have access to the PowerPoints. Yep. And if it's really hard to see, there's also a slide presentation on Canvas. Yeah. 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 Okay. Do not add imaginary stuff or real stuff just to try to make the other side balance. At least not yet. Right? Yeah. Oh, there's a little bit more to this story, right? It gets a little complicated, right? When you get into that higher chemistry, you'll understand. But at this point, you want to make sure that you don't do that, right? Because there's some logic, rhyme, and reason to that part of doing it. But you guys won't get there. Okay, so no imaginary stuff, no real stuff. Like, remember when he was like suggesting maybe we should just add another H, and then he fixed himself, he's corrected that real quick. He caught it, he recognized he was doing something wrong. Never add anything extra, right? Because that breaks the law of conservation. We always want to keep that law of conservation in check. So you guys want to make sure that everything adds up. What we put in, we must get out, okay? So I always like breaking it down in the middle. This is giving you another way of doing it. We know that there is the reactant. We know that there's the product. Split them up. Write down everything, right? It makes it so much simpler. Now, I'm going to show you a couple of quick ways of fixing things or understanding things a little bit better, right? If you pay attention to what's going on with the chemicals. And so this will kind of help you with doing that process, okay? Okay, so we won't do it again because you guys just did it. You already have it under control. Okay, so here it says, write the balance for the reaction of solid phosphorus pentachloride. I'm going to tell you what solid phosphorus pentachloride is in liquid water. Okay, so first thing it tells us that this compound is called solid. It's a solid phosphorus pentachloride. Phosphorus, what is the chemical formula or the chemical symbol for phosphorus? P. So we have phosphorus. Penta means 5, like a pentagram, right? You guys know your Greek numbers or Greek. So you know mono, mono, di, bi, tri, tetra. Okay, so you guys are going to be introduced to this when we start talking about nomenclature. But for now, I'm just going to walk you guys through it. Penta means 5, pentachloride. So that means I have 5 chloride. So it's phosphorus, Cl, and 5 would be my subscript for the chloride. And that is going to be reacting. We know that is it solid, liquid, or gas? It's a solid, so we're going to put an S by it. So we're going to put parentheses, and this is an S, not a 5. It's going to be reacting with what? H2O, solid, liquid, or gas. And it's going to yield. Yield means that line there, that's a yield line, right? It means to make. So it's going to make phosphoric acid. The chemical formula for phosphoric acid is H3PO4. And they tell us it's a solution. What does that mean for us? Aqueous, so we put AQ. And it's making hydrochloric acid. That's HCl. And we know that this is also a solution, AQ. Okay, so here's our question for you. Is it balanced? No, it's not balanced. How am I going to balance it? Going to break them up. Okay, so I have oops. And everything looks the same color there. Let's see if I can do this right. There we go. So we got a P, we got a Cl, and we have an H and an O. Okay, on the reactant side, how many P's do I have? How many Cl's? How many H's? How many oxygens? On the product side, how many hydrogens? How many chlorine? How many phosphorus? How many oxygens? Is it balanced? Okay, so it's not balanced. Okay, so where can I start? Is phosphorus doing okay? Okay, so we're going to leave phosphorus alone for right now. What about chlorine? Okay, so what do I need to do? Add a 5 to product side or a reactant side? Okay, so here. Okay, in front of the HCl. Okay. Okay. So then that gives me 5 chlorine. Now, how many hydrogens do I have? I have 8. Okay, so I have 8. Is that balanced? I have 2 on one side and then I have 8 on the other. No, what do I need to do to balance it? Right here? Okay, so that gives me 8. And how many oxygens do I have now? Now, is that balanced? Are we good? You guys got it? Simple, right? Not too hard? That was an easy one. You guys want something a little more challenging? This is a piece of cake, right? Okay, good. Let's move on. Okay. Okay, so the way that we interpret chemical equations, right? It's real simple. You're just telling me how many hydrogens they're going to take to react with how many oxygens to make water, right? So at a particulate level, particulate, what does particulate means again? Okay, something that we can't see with the microscope or our eyes. We have to use a special instrument to see it, okay? So at a particular level, we're basically saying if we have 2 molecules of hydrogen, 1 molecule of oxygen, we can make 2 molecules of water, right? Simple. That's what a chemical reaction is telling us. That's what we're interpreting. On a larger level, or at a microscopic level, or a macroscopic level, we can get away with saying, if we have particularly what we call a molar level, right? And I'll tell you what a mole is later. Actually, I can tell you what a mole is now. Okay, so let me ask you something real quick. We're going to go take it a little aside, kind of get us back full circle. A mole, okay? 1 mole. Do you guys know what a dozen is? 12, okay? Okay, so if I told you I have a dozen of wives, how many wives do I have? If I have a dozen donuts, how many donuts do I have? If I have a dozen of husbands, how many husbands do I have? If I have a dozen of kids, how many kids do I have? Okay, so you're telling me anytime I use that word dozen, it means 12. Okay, and that's quantity, right? We recognize that being quantity. Okay, so when I talk about a mole is very similar to a dozen. It's not 12, but really a mole is, let's see if I get this to right. Oops. It's 6.022 times 10 to the 23rd. Okay, so if I tell you I have a mole of wives, how many wives do I have? Okay, so I want you guys to say this together. So this number is called Avogadro's number, right? A lot of people, Avogadro's number. A lot of people will say avocado's number because it's spelled very close to the same, right? Avogadro's number. Avogadro's number is 6.022 times 10 to the 23rd. That's going to be 1 mole. 1 mole is always equal to 6.022 times 10 to the 23rd. Now say it with me, 6.022 times 10 to the 23rd. Okay, so now tomorrow, I want to see tattoos of everybody that has Avogadro's numbers written on their arm, right? Okay? Okay, I won't see you tomorrow on Tuesday, right? So I want to see those tattoos, right? Everybody's going to get Avogadro's number tattooed on them, right? So that way you'll remember it, right? Okay, it's a joke. Don't go get tattoos. Okay, so now if I said I have a mole of shoes, how many shoes? Now I should say, how many pairs of shoes do I have? If I said I had a mole of pairs of shoes, how many pairs of shoes do I have? Okay, if I said I had a mole of donuts, how many donuts do I have? Okay, simple, right? Okay, so I'm ask you this question. Now I want you to think about it just for one minute. I want you to think about it. Okay, so if I have a mole of pennies and I have $100 billion, which one would I want? And now let me let you know something. I'm greedy. Which one is going to be more? Okay, which one would you want? Okay, would you want a mole of pennies or $100 billion? Okay, so we know that $1 equals how many pennies? 100. So if I divide this by 100, this guy is going to be equal to 6.022 times 10 to the 21. We know that $1 billion, this will be dollars. $1 billion is $100 billion is 1 times 10 to the 6, 7, 8. Okay, which one would you want? You're satisfied with just a little bit? Is that what you're saying? I'm not. I want it all. If I can get it all, I'm gonna get it all, right? I told you I'm greedy, right? Okay, so clearly this is more. So that kind of gives you an idea of how much is there. Now, the reason why we use a mole is so that we can see stuff, because molecules are so small. If we don't use a mole, we won't be able to see it. If we can't use a half a mole, we won't be able to see it, right? If we're looking at a single molecule, we'll never see it. But we need a whole bunch of them to be able to see. Okay, so that's what a mole is. Okay, and we will talk more about a mole later on. I just wanted to introduce it to you early. Okay, are you guys with me? Didn't lose anybody. Okay. Okay, so like I said, 2 molecules of hydrogen gas, 1 molecule of oxygen gas will make 2 molecules of water. Simple, right? You see how it works? This here is looking at a dozen. If we have 2 dozen of hydrogen gas, we have 1 dozen of oxygen gas. That's going to make 2 dozen of water. And if we did the same thing with a mole, if we had 2 moles of hydrogen gas and 1 mole of oxygen gas, that's going to make 2 moles of water. You see that proportionality. You see how it works. So we can scale up. How many of you guys cook? Do you guys have big families or small families? Big families?
Have.
Half? Somewhere in the middle? Okay, okay. Okay, so if you're cooking just for yourself, right, you're gonna use a small amount. If you're cooking for a family of 10, you're gonna scale up. Now you should scale up proportional to everything else, right? Otherwise it don't taste right, okay? So let's say we're baking a cake, right? So normally, let's say we're going to do a box cake. We're not going to get fancy. We're just going to do a box cake. So in a box cake, how many eggs do you typically add? 3 eggs, okay? You add 1 box cake, the cake mix, right? 3 eggs, and we'll say butter, because we're not going to use oil, because oil isn't as good as butter. We're going to say a stick of butter, right? Okay, we're making a cake, and we say 1 cake will feed, we'll say, well, my family would only feed 3 people. My family are a big family, right? We're a big family, right? So it feeds 3 people. 1 cake feeds 3 people. So if we have 15 people, how many cakes do we need to make? 5. So am I going to add 1 egg to box cake mix 5? No. How many eggs should I be adding? Okay, so it has to be proportional, right? So you guys understand that, right? Otherwise, it don't come out right. Okay, our cake is all screwed up. We don't want that to happen. So that's the same thing with chemical formulas. Cooking is just using chemistry. Okay, so if you have to scale up for that, you also have to scale up for this, right? Simple. Okay, so let's move on. Okay, so you guys know how to balance chemical equations. You guys understand how chemical equations work, and you guys know how to interpret a chemical equation. You guys are already ahead of the game. We're in chapter 8 already, and we just started the other day, right? Isn't that pretty good? Okay, so that's good. Okay, so now the other thing that you guys need to know is the type of reactions. So understanding the types of reactions can kind of help us understand what's going to happen when we put those together. Okay, so I'm going to talk to you guys about types of reactions. And then we'll balance a chemical equation. Okay, so the first one that we're going to talk about is called a combination reaction, or called the synthesis reaction. Combination basically means you're putting 2 different things together and you're making a new thing. Combination, okay? Simple? So, and then also it could be 2 or more things. So technically it could be like 6 things coming together to make 1 thing. That's kind of like our cake. To make that 1 cake, we have the box mix, we have the eggs, we have the butter, right? And we bring that all together to make a cake. Okay, so I will write the chemical equation initially, and I want you guys to help me balance it. So, but you guys can help me out a little bit with writing it out. Okay, the question says, write the equation for the combination of solid aluminum and gaseous oxygen to form solid aluminum oxide. So what does solid aluminum look like? Al. Okay, let's see. Okay, is that a solid, liquid, or gas? Okay, and we have gaseous oxygen. Okay, I'm gonna write what you guys tell me. Is it just O? It's O2. Why is it O2? Because it's a diatomic element. That is correct. Good job. Who is that? Say your name. Minerva? We have Minerva. Okay, is that a solid, liquid, or gas? And we're gonna make aluminum oxide. Now, aluminum is gonna be Al. And I'm gonna write this down and I'll explain it to you guys later. We haven't got to the point of how we go about naming it and giving it balance, but oops. There we go. Al2O3. So that's the chemical formula for aluminum oxide. Is that solid, liquid, or gas? It's a solid because they tell us solid aluminum oxide, right? Okay, Okay, so now we have these two guys that come together. We have aluminum and oxygen coming together to make aluminum oxide. So is this balanced? No. Okay, so how many aluminums do we have on the reactant side? How many do we have on the product side? How many oxygen do we have on the reactant side? And on the product side. So we know that it isn't balanced, okay? So what do I need to do to balance it? Add a coefficient. Where am I adding a coefficient to? Over here? Okay, so then that gives me 2 aluminum. Okay, are we done? Is it balanced? No. Let's see, Kalinga, what do you guys think? So, okay,
Add 1 to oxygen.
so, okay, so
The oxygen.
So they said at Avenel was saying we put a 2 in front of the product, right? And so then we end up with 4 aluminum and 6 oxygen. And then you said put a
3 in front of O2.
3.
Yeah, then the 4 in front of aluminum.
Okay, is it balanced now?
Yes.
Okay, piece of cake, good job. Look at this, we got some chemistry going on here, right? Pretty simple, not too hard. Okay. Are you guys ready for the next one? Want something a little more challenging, right? It's getting too easy now. Okay, everybody got this down so I can move forward? Oh, I'm talking to all of you guys, so yeah. Okay, so the next type of reaction is called a decomposition reaction. So decomposition basically means breaking down. So we're going to be breaking things into individual components. We can break it up to individual elements, so they could be pure substances, pure elements, or we can break them down to compounds, okay? So in this case, we have AX is being broken down to just A and X, okay? Let's see. Okay, water decomposing into elements by electrical energy added. So we're going to write the chemical formula. So water, what is the chemical formula for water? And it's being decomposed into its elements. What are the 2 elements? Somebody said H2 and O and O2. That is correct. Why is it O2 and not just O? I heard somebody said it's a diatomic. That's right, because we know it's a diatomic element. Good job. Who was that? Ashley? Go ahead, Ashley. Okay, so the next part is water. Is water a solid, liquid, or gas? Okay. because we put energy into it, right? You put energy into it, you put heat into it, what's going to happen? Okay, so is it balanced? No, what do we need to do to balance it? So we have HO. How many hydrogens do we have on the product side? I mean, on the reactant side? And on the product side? How many oxygens do we have on the reactant side? Okay, what do I need to do to balance it? You said take away one of the oxygens? Okay, how do I need to add an oxygen? Coefficient? Two here? Okay, put a 2 on the reactant side. Okay, I got you. Okay. And then, so that gives me 4 and 2. Okay. Okay, a 2 on the product side in front of the hydrogen gas, right? You guys got this? Look at this. Okay, so then that gives us 4 over here. So we're good to go. It's balanced, right? Not too hard. Okay, any questions so far? Okay, good. Our next reaction is called the single replacement reaction. Okay, it's also often referred to as oxidation reduction reaction, or we call it redox for short. I like to call it replacing the old girlfriend. Okay, let me tell you why. Okay, so here we have B and X that are together, right? B and X are together. So now we're dumping B for A because A is cuter. So we're replacing the old girlfriend for the new girlfriend, right? So we get AX now. Okay? Do you guys get that? So you're just basically replacing one for the other. Okay? Now there are rules to replacement, right? So you're replacing a metal for a metal, or you're replacing a non-metal for a non-metal. You never replace a metal for a non-metal. Except there's one special case, and that's hydrogen. Hydrogen is kind of funny. Hydrogen is like, yes, sir. Yes, so you replace a metal for a metal, or you replace a non-metal for a non-metal. You never replace a metal for a non-metal, except for one case, and that's hydrogen. Hydrogen is kind of that funny case, right? It's that really, really, really hot transsexual that you replace for your old girlfriend. Celebrating Pride Month. Okay. Okay. You guys kind of understand that? You see what it is? So you guys want an example? Okay, so here, copper reacts with a solution of silver nitrate. Okay, so I'll tell you what silver nitrate looks like. You guys know what copper looks like. What is copper? What is the chemical symbol for copper? Cu. Sorry. And we know that copper is a metal, so it's going to be solid, liquid, or gas. Silver nitrate is going to be silver, Ag, and NO3. And they told us it's a solution, so it's aqueous. That is correct. Okay, so when we do this replacement, we get a metal replacing the metal, so copper. And we're gonna get, and this is gonna be important here because we haven't done this yet. It's gonna be what we call copper 2. How about I remove this? AQ. Okay, AG stands for silver, right? Okay, so is this balanced? That's an S. Okay, so we know that this is imbalanced. Okay, so here we have parentheses, we have the nitrate in parentheses. So nitrate, that means that we have 2 nitrates. So altogether, if I have 2 nitrates, how many total nitrogens do I have? I have 2. How many total oxygens? Oops, I'm sorry. So if I have 2 nitrates, each nitrate has 3 oxygens, and I have 2 nitrates. Okay, let me write it down. I told you I have 2 nitrates. I have 6 oxygens. That's right. Good job. Who is that? Angel. Okay, so we add those all up. That'll be 6 oxygens. How many coppers do I have? 1. And then silver. 1 and 1. And here we have 3 oxygens and 1 nitrogen. Is this balanced? Okay, what do I need to do to balance it? Okay, I need twice as much oxygen. So what do I need to do to make twice as much? I need to. Right here? Okay. Good job. Oops. That's 2. That's 6. That's 2 and 2. Okay. Sure. I can explain it for the slow people. Okay. So since we know that over here we had 6 oxygens, right? Because this coefficient here, I mean, not coefficient, this subscript pertains to this whole compound. So this is like a compound in a compound. We call this guy a polyatomic ion. This guy in here is called a polyatomic ion. I'll explain it later, I promise. So we take this number and we just multiply it by both of these. So that's multiplying it by 3. So that's how we get 6 oxygen. We take this number and multiply it by that 1 that's understood. That's how we got 2 nitrogens. You guys got that so far? Okay, so then we know that there's no subscript next to the copper. So that means that it's 1, right? Now, initially we had 1 silver, initially until we got the coefficient. So that meant that on the other side, we had 1 nitrogen, we had 3 oxygens, 1 nitrogen, 3 oxygens, 1 copper, and 1 silver initially, right? So the only way that we could get 2 nitrogens is by putting a 2 in front of the whole thing, right? So that means our coefficient is going to be a 2. So then that means now that we have 2 silver, 2 nitrogens, and 6 oxygens, 6 oxygen. Okay? We didn't have to do anything to the copper because copper was 1 and 1. You guys got that? Okay, good. So can I clear, or do you need a little more time? Clear. Okay. Now don't worry, you're going to have homework assignments that are going to take you through this in a lot more detail. So, okay, so our next type of reaction is called a double replacement reaction. You guys aren't old enough for this, but I'll say it anyway. Okay, so in a double replacement reaction is that you're switching partners. I often will call this a swingers reaction, right? Okay, so usually with a double replacement reaction, you're going to end up with a precipitant. Usually, not always, right? So you're exchanging one for the other, okay? So here, A is going to hook up with Y, and B is going to hook up with X. Okay? You guys got that? Simple? You guys want to see how it works? Okay, so we have silver chloride precipitates when solutions of sodium chloride and silver nitrate are combined. So they wrote the equation a little different. So this is our product. The silver chloride is our product. So what does silver look like? What is the a what? Silver? Ag. Ag. And chloride? Cl. Yes. Yes. Okay. Now they say it's a precipitant. What did we say about precipitants earlier? Is that a solid, liquid, gas, or aqueous? It's a solid. That's right. Because it precipitates out. It drops out. So anytime that you see the word precipitant or precipitates, that means that it's a solid. That's right. Okay, it says sodium chloride. What does sodium chloride looks like? NaCl. And it says solutions, aqueous. And that's going to make silver nitrate. What does silver nitrate look like in the problem before? AgNO3. That's right. Aqueous. That's right. Okay, now we know that the law of conservation says what we put out, we must get in. We know that this guy is a double replacement reaction. We're replacing one with the other. So if you guys look at this, we got AgCl as one product. So what is going to be my other product? NaNO3. That is correct. And that's right, it's going to be aqueous. So if they don't tell you anything about it, it's understood that it's going to keep the aqueous form. AQ. Okay, is it balanced? Are you sure? So if we take a look at it, we'll break it down. Oops. NO, Na. Now remember, that's a Cl, not a Ci. Okay, so sodiums. How many sodiums do we have? One. So we have one sodium on the reactant side. And how many do we have on the product side? Chlorines. How many chlorines do we have on the reactant side? And on the product side? Nitrogens. And on the product side? Oxygens. And on the product side? Silver. And on the, okay, balanced? Questions, concerns, cash? Cash, I always take cash. You do too? Yeah. How much for an egg? $2 million. It used to be $1 million, but you know, inflation, so it has to go up, right? I drive a blue Scion that the paint's pulling off the front. So anytime you want to give me some extra cash, donate it to the college fund, you know, Dr. Henry's college fund, you know. Okay, so there are special cases of a double replacement reaction. A neutralization is just a special case of a double replacement reaction. Neutralization, we make reference to when we have an acid reacting with a base. When we get an acid reacting with a base, a strong acid and a strong base, we're going to end up with water and a salt. Okay, so if we get a strong acid reacting with a strong base, we're going to end up with water and a salt. Okay, here we represent the X is going to be HX represents the acid. Now I'm going to tell you something here real quick, and it's going to be a little bit harder to understand because you guys don't have enough stuff underneath your belt. But anytime that you see hydrogen and let's say another non-metal with it, and it has aqueous next to it, that typically means it's going to be an acid. Okay, so for instance, if I have HCl, hold on. HClAQ, anytime that you see hydrogen with a non-metal, it's going to be an acid when you see that AQ with it. Hydrogen with the non-metal, it's going to be an acid. Okay. Now, a common base that we have. Thank you. I appreciate it. So if we have a metal with an OH, that's typically a base. Okay. And bases can either be solids or they could be AQ. In this case, we're going to make it solid. So when we put an acid, a strong acid, and a strong base together, we're always going to end up with one product that's going to be water, H2O. So if you take a look at it, it's still a double replacement reaction. This guy is going to hook up with this guy. And then the sodium is going to hook up with the chloride to form a salt. And this guy is going to be aqueous. AQ. Okay, questions, concerns, Kat? Good. Okay, is it balanced? Yes, it is balanced. Yeah. It's a Q. I know it looks like a G. It's a Q. It's a Q. Okay, questions, no questions. Okay, let me give you an example. You guys ready for an example? No yawning. Yawning means that you have to bring in a cake next week with coffee, yes. Or, oh, hot chocolate would be good. Okay. Write the reaction between sulfuric acid and solid aluminum hydroxide. I'm going to write down the chemical equation. You had a question? Go ahead. Sulfuric acid is H2.
Dr. Henry,
SO4. Yes.
you had a question in the chat.
Oh, I have a question in the chat. Hold on. Yes, acids. Okay. Acids are 99.999% of the time going to be aqueous. There are a couple of acids that can be solids, and we'll talk about that. Those are mostly organic acids. We'll talk about that later on. Okay? Does that answer your question, Luis? So the question was, are acids always going to be aqueous? 99.9% of the time they are. The only time that they're typically not is if it's an organic acid. Those are kind of special acids. Okay. Okay, and we have solid aluminum hydroxide. Aluminum is Al, and hydroxide is OH, and we're going to need 3 of them to balance it out. We'll talk about that later. And we know that this is a solid, liquid, or gas. 3. Solid. Okay. So we know that we're going to get salt and water. So we know we're going to end up with H2O because we have a strong acid reacting with a strong base. And our other product is going to be aluminum sulfate.
Professor, I have a question.
Yes, ma'am.
Okay, so the parentheses come into play when the word between is within the equation?
Not necessarily, no. So the parentheses become in play when, so let me kind of give you a little bit of a clarification without giving you complete clarification. So
Okay.
the way that we use parentheses lets us know that we have multiple of what's inside, right? So
Okay.
to balance out certain equations, sometimes it'll take more of something to balance it out than others. And we'll talk more about this when we start getting into nomenclature officially, right? Right now, we're just worried about balancing equations, okay? So
Okay.
I'll put the parentheses in there for you right now, but I'll show you how to do it later on, okay?
Yeah, because I'm kind of confused, like why the last equation didn't need a parentheses, but this one we're
Yeah.
using parentheses.
Okay, so this one needs a parentheses because it takes 3 OHs to balance out the aluminum. And so the normal chemical compound for aluminum hydroxide is always going to be written Al parentheses OH3. Okay, so that means that there's 3 OHs for that one aluminum to balance it out. Does that make sense?
Yes.
Okay,
Fine.
so let me put it in terms of like real life, okay? So You know how like a guy that considers himself a player will always have like 3 girlfriends, right?
Okay.
And if he doesn't have 3 girlfriends, he's not a player, right? So to
Okay.
be a player, you need 3 girlfriends. So aluminum is kind of like that guy. It needs 3 OHs to kind of keep it satisfied. Does that make sense?
Yeah, but I'm trying to figure out like why does it need the parentheses though? I don't get it.
So the parentheses, we need the parentheses to let us know that there are going to be 3 of whatever's inside of it, right? So
Oh, okay, 3 of each.
that's right. So
Got
yes,
it. Okay.
aluminum needs 3 of these guys, 3 of these.
Right.
So really, there's 3 individual OHs around aluminum.
And 3 oxygens, yeah.
Well, so in that case, that's right. It'll be 3 oxygens and 3 hydrogens. Yep,
Right. Okay.
that's right.
Okay,
let me
yeah,
get-
not
Yeah, good question though. Oops. Give me 1 second while I shift things and finish balancing out the equation. How are we doing on time? Time? Actually, we're gonna, yeah, they're gonna get a break. But I'm gonna keep them a little bit so before I give them the break. Oops. Okay. Okay, so here we have this chemical equation. Is it balanced? No. Okay, so what do we need to do to balance it? Okay, on the reactant side, how many H's do I have? I have 2 and I have 5. How many S's? How many O's? I have 7, so I have 4 here. And then we have, so that's 7. And aluminum, how many ALs do I have? 1. Okay, on the other side, I have 2 hydrogens. How many sulfurs? 3. How many oxygens? So 3 times 4, 12 plus 1. Aluminum. Is it balanced? No. Okay. How do I balance it? Oh, I guess that means there's a break for you guys. Not yet. You guys have to hold on. Hold your potty right now. We'll finish this one because we only have 1 more slide left after this. Is it balanced? No. Okay. So what do I need to do to balance it? I need to put some coefficients in, right? Where am I going to start? It's a hot mess, huh? Yes, ma'am. Of the H, so I have 3 times, yep. Okay, so, so maybe let's start with the aluminum. Let's start with the aluminum at the bottom. Okay, so if I have the aluminum, if I put a 2 here, okay, so then that gives me 2 down here. That means now I have how many oxygens over here? So that's 6 plus is 10, okay? And how many hydrogens? 6 plus 8. Okay, now let's see, let's go to that hydrogen then, because we can make that simple, right? Put a 4 here. Okay, so I have 8. How many oxygens do I have now? 4 plus, is that 12? So then that's a total of how much? 12 plus 4? 16. Okay, now what about our S's here? Put a 3 here. Oh, so that's going to shift everything around again. Okay, so but that gives me my 3 S's. How many hydrogens do I have now? I have 6 here plus 6 here, 12. How many oxygens? So I have 12 plus 6, 18, my age. Okay. Okay, so, and then, let's see, on the other side. So how can I fix this so that we can end up with 12? If I change the 4 to a 6. Okay, so we're going to put a 6 here instead. And that gives me 12. That gives me how many? 18. That's right. So 6 plus 12, 18. Is everything else good? Is that balanced? Good. Okay, last slide. Okay. These are your different types of reactions. You want to be familiar with your different types of reactions because they're going to help you figure out what you should expect. Okay? Okay, let's take a break. You got Alvin, I'll take a break. I'll see you guys on Monday. You guys have a good weekend. Do your homework and work on your lab reports.